So why am I here and why am I talking about this topic? Well, first of all, I was involved to some extent, yes, but for sure I was not somebody who had any significant role in that universe, neither in the BBS scene nor in the early internet days. I was just basically a youngster, a teenager who had fun playing with technology and was helping others to communicate using technology. There are many more people who are much more qualified than me to talk about that subject, and that's the reason why I'm here and why I submitted this talk, is you don't really see many people speaking about these days or about those topics anymore. And even if you want to research it, I think there's like 1 or 2 books in German on that subject. They're very hard to get and also not very complete. So I think we have to sort of document the history a bit for those people who have not been around at the time. So this talk will not have as many acronyms as you used to from talks that I usually give. Still, you have typos in the slides, as you can see on the second line already, so that didn't change. I didn't invent any of the technologies covered here. I didn't write any of the software covered. I was just a user and operator or sysadmin. And that's the world I grew up in from 11 onwards. As I said, many people lack that history, and to start with that, maybe a quick poll in the audience. Who has ever dialed into a BBS using a modem? Raise your hands. Okay, so I'm preaching to the converted. Maybe I should invite all of you up to the stage and we should make a discussion round instead. Circuit switch telephony. Well, this is the telephony from 1876 until about 1988 with analog voice circuits over copper wires and dial-up connections between A and B. I guess everybody still remembers these. Even if you're young, you should have seen a classic telephone, I think. You have analog amplifiers possibly in the path, but actually the copper wires are physically switched at telephone exchanges. So this then structurally looks a bit like this. We have a telephone at one end, we have a telephone at another end, and we have telephone exchanges or switches which actually switch the circuit, hence the term circuit switch telephony, between A and B. So you have a copper wire from your phone to the office, the exchange, to which you are connected, and then that exchange again has copper wires to other exchanges and so on, and based on the phone number you dial, the call is switched to the destination subscriber. That's sort of the foundation in terms of technology that we're using here. Also something to document for the international audience. In Germany at that time, even local calls were metered and charged by the minute. Flat rates didn't exist, and we had multiple zones, so there's not just local calls and long distance calls, but different depending on your distance, so like up to 50 kilometers or more than 50 kilometers and so on. Given on that and the steep pricing, not so many people could afford long distance BBSing, at least not for a long time. all of this started with a device called the acoustic coupler. It's actually also how I started, even though I'm young and I only started in, I think, about 90 or 91. At 10 or 11 years of age, you don't have the latest and greatest in technology. I got a used second-hand or third-hand Olivetti acoustic coupler from my uncle. It had even a battery. It could be operated mobile. It had a battery compartment with 8 Mignon cells. Actually, I still own it, and I still own a related telephone. I just thought don't have to bring it here, but it still exists. So anyway, here you have to dial using your normal phone. You dial the digits of the phone number, and once the other side picks up the phone and they put their receiver onto the acoustic coupler, and you put your receiver onto the acoustic coupler, then data can be transmitted over the telephone line, as I said, with manual dial, manual pickup, and rather extremely low speed. This all looks like this, and the next step in the logical progression then was modems, which is sort of, you can think of an automatized method of acoustic couplers, where you don't have an air gap anymore. So in the acoustic coupler, you literally have a couple of centimeters of air between the speaker and the microphone in the receiver of your phone versus the acoustic coupler. So with the modem, there's a direct connection, and also you have automatic facilities to dial the telephone number and to answer the line and so on. So you don't need a manual operator anymore to pick up a phone or dial numbers. And this then gets transmitted over the telephone line. This is a stack of various different modems. We will see some others here. Some of you will remember the brands or the shapes or even the specific models of those modems. But that's too much level of detail for the moment. So let's look a bit at the speeds or lack of speed that was available. It started with 300 BPS. I actually used 300 BPS a couple of times back in, like I said, around 1990. Of course, it was extremely slow, but still it was what I could start with at the time, or then the 1200 BPS. So this is still rather slow, and you can slowly read and follow the text as it's being printed. Unfortunately, I don't have an animation or something like that. I'm not such a multimedia savvy guy. Then the speeds progressed. You see the years in which they were created, the lines with the asterisk mark years that I found some secondary sources that originally it had been specified then, but actually the oldest spec document for all these earlier ones was from 1988. So if you go to the ITU website, the earliest documents you can find are from 1988, and none of those earlier documents could, at least on the internet, be found anywhere. Maybe you can go to a library or something like that. So speeds progressed, different modulation schemes were introduced to squeeze ever more bits into these 3 kilohertz analog circuit over the telephone line. Every couple of years, new, especially in the 90s, if you follow this, 91, 14.400 BPS, 93, 19.2, 1994, 28,000 bits per second. And there were, of course, also proprietary protocols. Then you had to have the same manufacturer of modem that the other side whom you're calling, and so on. But these are the official standardized protocols and speeds that were used, which brings us. So, okay, we have a telephone system. We can dial numbers. We have a modem that can dial numbers. We have modems that can send bits in exceptionally fast speed. What do we do with this? And this brings us to BBSs. Where could you actually dial, and what could you do there? So what's a BBS? Fundamentally, it's some computer, any hardware, any operating system, any software, some computer that accepts incoming calls attached to a modem and offers some kind of interactive service to the people who dial into that BBS. And if you wanted to operate a BBS, you had to have a separate dedicated computer for that, because at the time, most of the BBS software and most of the software that people used in general predated multitasking operating systems. So when you ran the BBS, the computer was busy running the BBS. You couldn't do anything else at the same time. So you had to invest quite a bit into a separate second computer, or third or fourth, to actually operate that BBS. You had to have a separate telephone line because if you operate the BBS into which people dial into, of course, any time of the day or night, people will dial in there, so you cannot use your normal phone line that you use to make phone calls, but you had to have a separate dedicated phone line. And of course, the system had to run more or less 24/7, so people could dial in and reach it. Luckily, on the user side, there was not so many requirements in terms of technology that you needed. Your computer, of course, you only power when you use it, and you can share the regular phone line with the side effect, as in the introduction has been mentioned, that your family might have gone angry if you occupied it too long. But otherwise, no additional infrastructure other than a modem required. Now you dial into the BBS. What kind of content do you get, or what do you do in that BBS? And the name BBS in English is the Bulletin Board Service. That's actually the acronym expansion. So there were bulletin boards, message boards, where you could exchange messages and texts with other people, other users of that BBS, or the so-called sysop, the system operator, the guy running that BBS. You could also chat with the system operator, which, didn't exist before, the ability to chat with somebody else remotely over a text-based terminal. There were also multi-user games, text-based, as well as so-called file areas where you could download files. And downloading files, given the speeds back then and so on, of course, it was it was primarily text documents or small programs or something like that. MP3 didn't exist, of course, at least until 95 or whenever it came out, so maybe some mod files for your module tracker, something like that. And of course, last but not least, ASCII and ANSI artwork, which basically is an entire subculture and scene and community in itself, creating artworks and drawings using the character set that was used by ANSI.sys, which was the DOS could say display driver in quotes in a certain character set, and you could draw graphics like this. We will see some more, and people were putting a lot of effort into this and sort of competing who could make the best representation or the most expressive artwork, given the limited resolution and the limited characters and colors available in this domain. So what kind of software did one use, or what kind of technology was used? Well, we already had the computer and modem. You needed some software. So on the BBS side, BBS software, there's an unlimited number of different BBS software programs and extensions and modifications thereof. A lot of them are freeware or shareware. Some of them are public domain. Some are actual free software. Some are proprietary. For any operating system, for any computer architecture, people were writing BBS software, whether you had an Amiga or Atari, or you had Apple or DOS PCs, or you name it. Software was written by hobbyists primarily. One concept that you will find in BBSs is the concept of so-called doors. You can think of it as similar to CGIs in web. So basically, the BBS software could call an external program which would then take over the input and output to and from the user. So you could have sort of plugins to your BBS software which would add additional new games or chat software or messaging or whatever. On the user side, you had primarily a so-called terminal program. It's called terminal program because actually it emulates a serial terminal, which is a dedicated hardware device with a keyboard and a screen and a serial line, but not a general purpose computer. And in order to make a general purpose computer behave like a terminal, you had a terminal program on DOS, which I was using at the time. It's primarily Telix and Telemate, I think, were the favorite ones, at least on this side of the planet. You started that program, you had a serial port, the serial port attached to your modem, and from there you dialed, and the terminal program then was responsible of displaying the texts and the ANSI graphics and so on, and exchanging files over a variety of different protocols, which we will also cover later. But before we go on, let's do a quick demo of how this looks like. Now, as a note, I don't have a modem here. I'm not emulating a modem. I'm not emulating a serial port. These days, you can get the same experience by using Telnet over the internet, but you can actually Telnet into BBSs. I just want to basically show how it looks like. This is the terminal program, and we have now connected to the BBS. This is sort of an introductory graphic that we see before even logging into the box. Of course, the scrolling was much slower back then. So now we can scroll back up to actually see what was there. Some more graphics. You still haven't seen the login prompt yet. As you can see, a fairly graphics-heavy BBS. Then you can choose the theme of the BBS user interface. I'm going to go for the classic ANSI here. Finally, I come to a login screen, and I can log into the system, where I have to enter my handle and the password, which is now in clear text over Telnet. For those of you interested in it, it's not that there's anything useful. I just registered this morning at the BBS, so there's nothing associated with this account. Some more graphics. Finally, we are at a message board, and we see, as I said, I just logged in or registered at this BBS today. We see there is a message number 1 from Hawk Hubbard, welcome. So if I want to look at that message, I could basically say I want to read it now. This is the message reader. I go in here, then here, welcome LaForge, and so on. So he welcomes me to the BBS. Let's go to the main menu of the BBS, which in this case looks like that. You have different the file areas where you can download files. You have the Dory games that I mentioned. You have an ANSI gallery, a BBS list. You can look at the last callers who has called this mailbox, and you can see there's 3 test calls from me this morning. But you can see actually other people are still logging into this BBS, and it's 2017. So it's not to me this is mostly history. But during the preparation of this talk, I discovered that for some people it is still the present, and I'm very happy to see there's still such an active community around BBSs, and which enables me to show all of this without firing up some emulators and so on. So we also can look at one-liners. This is some messages that people can leave to other people, other users in the BBS, again with some quite graphical. We don't want to leave any additional words here. But for example, we can look at the ANSI gallery just very quickly. Can try to select something here. I have no idea what I'm looking at, so okay. So here you have a sort of a viewer that so it will show you the sections of a sort of longer artwork in this particular case. Well, ANSI artwork. To me, there always was a lot of similarity between the between the ANSI artists and the people doing. Now I'm lacking the word. Street art. Basically, I think there's a lot of similarity between that. Okay, good. That was just a very quick demo. Of course, I could now look at more messages and write messages and play blackjack and do whatever I want, which I don't in this case. So we will log off. And again, some more graphics, and you can leave a comment to the sysop if you want, or you can just basically log off. Okay, that for a very quick demo of the look and feel. Now, since I'm such a technical person and looking at protocol stacks, I tried to draw a protocol stack diagram for BBSs, which ended up at this. So basically at the lower layers we have the POTS, the plain old telephony system, or ISDN, which we will get to in a few slides. We had modems on the analog telephone system. We had other things on ISDN. In the end, at some point, you always have RS-232, a serial port, either emulated or real. And then either you had a terminal program directly on top of that, or, for example, to transfer files, you have used X modem or Y modem or Z modem, which added error correction and retransmission and block transmission, so you could safely transfer files without, or at least with less corruption. And the checksum algorithms were not so scientific in many cases. Here we then have, well, some other things. FTN point, what is that? UCP, we will cover that later. Basically, you could run different protocols and different systems on top of that. One curiosity that I still want to mention is that, which I forgot until on Twitter somebody reminded me a couple of days ago that this existed, and I went, oh yes, RipTerm. I used that quite some time ago. So instead of having these text-based user interfaces, some people, a company called Telegraphics, came up with a language called RipScript, which was a fairly compact language of textual commands by which the BTS could control a vector graphic renderer on the client side in your terminal program. And you could actually draw EGA resolution graphics like the one that's presented here on the slide from the BBS on the screen of the user, which was quite a big change compared to the ASCII art or ANSI art that you've seen before. Yeah, so we're still at BBSs and BBSs that are isolated. So you can participate in those bulletin boards and you can read and write messages and exchange ideas and recipes and thoughts and cheat codes and whatever you want to exchange. Users log in at different times. The BBS is busy if it has only a single line while it's being used by some other user. Of course, you can add, as a BBS operator, as a sysop, you can add more modems and more phone lines, which is of course expensive. Together with the multi-port serial cards and everything that was required. You can have time limits for each user. Yeah, but in the end, it's sort of, there's a limit to how far you can scale a single BBS. Oh, GSM. A single BBS. Well, also there's a scalability limit for BTSs, but that's another talk. So, yeah, which brings us to one method of more efficiently engaging with BTSs for exchanging messages, which is the concept of points or offline message reading. So, as we have just seen in this example, we log into the BBS and we have an online interactive session with the BBS while we read and write the messages. And of course, it means we occupy the telephone line for an extended period of time, and it's not used very efficiently because humans typically read slower than at least 14.4 or 28 kilobits per second. So people invented something called points or offline message reading, different concepts, different systems, different standards, different technologies. What they did in the end is they compressed and batched all the messages for you into files, and you on your client side, you were writing your messages offline and also compressing and batching the messages that you've written, and then you make a call. You quickly exchange those files in both directions, even in full duplex if the system supports it, and then you terminate the connection again. So during a very short call, you can exchange much more, many more messages, and you have all the time to read through those messages without having to look at the phone meter or your phone bill all the time. So more scalability, more users, shorter connection time, lower cost for everyone involved, definitely an interesting technology. But still, sort of scalability is limited of a single BBS, which brings us to BBS networks, store and forward networks, which basically extended the ability to exchange messages beyond a single BBS. So basically the bulletin boards or the message groups that you had at a BBS were replicated over different protocols that were invented by various different people over time. So not only one BBS had all the messages of a given bulletin board, but all the other BBSs participating also were receiving these messages and replicating them all over the network. Also for personal mail, which is like email, right, between two participants, you could route those messages across the network. The two users exchanging messages didn't have to connect to the same BBS anymore. So much more scalability, and also you could use it efficiently for message routing to reduce the need for long distance calls and so on. So let's look at a couple of these BBS networks and the technologies they used. One large and very popular example, of course, is the Fido network, which consists of two parts, netmail and echo mail. Netmail is the private personal mail, and echo mail are public message boards or message groups. Fido had the technology used by Fido called FTN, Fido Technology Networks, were used also by other networks. They were using the same protocols, but they were not the same group of BBSs or the same content and so on. TrackNet for Star Trek fans was one. Garnet in Germany was an example for that. There also were other technologies and other networks such as ZNets, where they called it Bretter actually, so boards, the individual message groups. And again, they had other offsprings that used the same technology but had different groups and different policies and different structures, such as TNets or CLNets. And then there was the big faction of people who did UUCP, the Unix to Unix copy, which we will look at a little bit. And MouseNet is another German example here, originating from the city of Münster, which was used to up to 120 BBSs here. Let's look at Fido a little bit more. Started allegedly in 1984. Of course, I was not involved at that time, at the age of 5. It reached a limit of 250 nodes in 1985 because apparently, I suppose, probably a single uint8 was used for the node number or something like that, and then, well, 250 should be sufficient for everyone. I don't know what the other 5 are for. And then they introduced in 86 hierarchic regional routing and addressing that was more scalable. And in the end, at the peak of the FidoNet propagation, there was 39,000 nodes. That's BBSs, not individual users, but 39,000 BBSs were interconnected with an estimated 2 million users worldwide. And that's for a hobbyist amateur network is, I think, quite impressive. The addresses looked like this. That's actually a node number that I used around 95 in Nuremberg at the time. ZNets started as Cerberus nets, and I'm not sure if Padeloon or Rena or any of the people involved are in the audience. If then, I hope I represent the history correctly. Which is a network technology created in Germany. The standards are inspired but different than the Usenet and UUCP protocols, and there were all kinds of flame wars about who understood the specs wrong and whether there's an improvement between ZConnect compared to the Usenet standards or not. But anyway, it was different, and there was one program called Crosspoint, which was the most popular point software at the time, I think, at least on DOS, for ZNets and also for other technologies. The screenshot here at the bottom actually is a Crosspoint screenshot. And Crosspoint in the early 90s already had features that I'm still missing today in any email client that I have found, right? Imagine you have a thread that crosses multiple folders, multiple news groups, multiple whatever, and you have threading, like the tree of the thread across folders and news groups and so on. I mean, that's something that you cannot do with any of the software still today. Maybe you have an answer which software today supports this, but for sure nothing I have found has the kind of features and functionality. Unfortunately, it was written in Pascal, and it had a line length limit of 255 characters per line, which made it not very compatible to Usenet standards, where lines could have different lengths. So one couldn't continue to use it in today's time and age, at least not easily. Usenet is another network of these BBS days, where messages were exchanged by a system called Unix to Unix copy. Unix to Unix copy predates the Usenet. It was used, well, as the name implies, to copy something between Unix machines, file copying, and some of those files that people were copying were internet mail at the time. And then the Usenet news format was invented. The format is quite similar to internet mail, which we still know today, but it's not a personal mail between person A and person B, but you could post it to a so-called news group, and there was a hierarchy of news groups which replicated and flooded messages across the entire network across the globe. And there was a flooding mechanism involved to make sure that the messages get replicated and the duplicates get detected and duplicates are not basically transmitted again, or rather shown again. And so on. The routing was originally defined in route maps in UCP, which is quite a bit odd over time, because it's basically a static source-based routing for the UCP mails. News, as I said, they were flooding anyway. Usenet was quite popular until well into the 90s. I was newsmaster of 2 news servers for some time, basically doing system administration of those boxes. And just to give you an anecdote again into this context, we will get to Kommunikationsnetz Franken, which is a non-profit organization in the area of Franconia in southern Germany, where I was active. And at the time, internet, like when we actually got to IP at some point, IP traffic was so expensive that it was rather difficult to get a full news feed over IP, because you wasted a lot of your expensive bandwidth on, or wasted in quotes, but you used it for news. So what we did actually is we put up a satellite dish at a building in Nuremberg, and we had satellite feeds from the US. So there was were US companies that were streaming compressed Usenet batches up to a geostationary satellite, which has a downlink over Europe. And then we got 2 megabits of compressed batched Usenet news in, I would say, let's say 95-ish or something like that. So that was definitely a big improvement. So we had a full news feed coming directly from the US without having to pay for all the international data transfer. Another curiosity is the floppy polar point. Now, nobody is laughing yet. Well, not everyone had phone lines in the 90s, particularly in Eastern Germany. Phone lines were still a rare commodity after reunification happened in 90. Took some time until people could get connected to the telephone network. And so what people did is actually they exchanged daily floppies by postal mail. So basically, rather than sending your compressed batches of messages over modems, because, well, for modem you need phone lines, you put a floppy, I would assume 3.5 inch at the time, not so much 4.25 inch, but you put a floppy in an envelope, you send it to your BBS, and the guy opens the envelope and puts it in the BBS, and he sends you a floppy in return. So you add 1 day or something to your transmission, but then, well, the messages, the transmission speed of messages in those networks at the time was sort of 1 to 2 days, or maybe even 3 days anyway. So if you add another day, what does it matter? It was such a big advantage that you could get messages, like worldwide messages at all, in such a short time, and for basically no cost whatsoever. Okay, getting to the internet. Yeah, how did I start to access internet, or how did people start to access the internet at the time? Well, mail and news was sort of the internet in the beginning via UCP, which is nice and fine, but it's not IP yet. So what you could do is you could, instead of dialing into a BBS, you could of course use your modem to dial to the serial port, to the TTY of any Unix machine that's somewhere else. So if you have a Unix workstation somewhere that's connected to an IP network using 10base2 or whatever was the network technology at the time, or FDDI or whatever, X21, Then you could attach a modem to a serial port of such a Unix box, and you just get the login prompt when you connect with the modem to that box. Like you sit in front of your Linux system today, you have your login prompt, and then on that workstation, you could remotely use that workstation, and then you could run FTP clients or IRC clients or Telnet, Gopher, whatever on the text console. That was mostly available to people in the academic sector, of course, because they had some Unix machines at universities. I was too young to be at university, so I had to use FTP mailers for quite some time. So what's an FTP mailer? Well, it's basically some FTP client that runs on a remote machine somewhere that's connected to the internet and that has email access, and you can use input-output over email. So if you want to FTP to some FTP server, you send an email. It says FTP to the server and an LS. And then some hours later, you get a response with the list of the files. Yeah? And then after you got the list of the files, you do the first CD to change into a directory. And then you get again the response. And then finally you know which file you want, so you issue a get command over the file, and then you get this long series of UUN-coded mails. UUN code is a method of sending binary 8-bit messages over mails before MIME existed, the MIME format which we use today for email attachments and so on. That didn't exist at the time, so it was UUN code before. So yeah, so hours or days later you got that, and it worked perfectly fine. I mean, I was quite happy to be able to use that at the time. Now then, if you had dial-up access to a Unix box, you could also do something called SLIP, which is a serial line IP. So you could transport IP over the modem line, and as a result, you have IP at home in your apartment. Unbelievable. It was later superseded by PPP, which introduced features such as auto-configuration, authentication, compression, and so on. Well, there was a compressed SLIP, but yeah, not quite as compressed as PPP. And popular software stack at the time, and I'm talking about early 90s, mid-90s, is basically Trumpet WinSock on Windows with NCSA Mosaic as a browser. Because Windows back then didn't have TCP/IP, so you had to install another package to actually have TCP/IP on Windows at the time. If you didn't have Windows, I will get to that, and I'm talking about the pre-Linux days here. So what did you do if you wanted to do internet on a PC before Linux was around? I didn't have a 386 initially, I had a 286. And on a 286, of course, you couldn't run any multitasking operating system because it doesn't have a real protected mode. So no Linux, no BSD, but there was something called KA9Q NOS. And now I want to see hands who has ever heard of or used KA9Q NOS. Yeah, okay. Huh? Yes, it's the person's call sign, was the comment from the audience. This is correct. KA9Q is Phil Karn in the US, and he wrote a network operating system, the KA9Q NOS, the network operating system. And it is an implementation of, he started actually in the 80s with this on CP/M and then later ported it to DOS, and it implements TCP/IP, SLIP, PPP, including POP3 server, SMTP server client, IP routing, Telnet, ARP, and so on. And you could do all this on DOS. I used it quite a lot at my home. You could do routing, and you had multiple applications at the same time, all on top of DOS. It was a fantastic piece of software. Then you could build a router to Ethernet, and you could have multiple other machines in your home, and you have more and more cable in your home. And more connected machines. Yeah, actually, yeah, we will get to that. Okay, PPP superseded that. At some point, ISDN came around, particularly in Germany. ISDN is a digital version of a telephony system, so instead of having analog circuits, you now transport digital bits. That could be audio, digitized audio, but of course it could be any other transparent digital data. In Germany, ISDN was first put in operation in 1989. Until 93, it used a German protocol standard called 1TR6, and from 94 onwards, the European EDSS1 protocol standard was available. It was hugely popularized from 1995 onwards by subsidies. So at the time, if you actually ordered an ISDN connection, and at the same time you bought let's say a small PBX or a phone or a modem or something like that, you got subsidies from Deutsche Telekom. So I think it went up to 700 marks. I'm not sure if somebody remembers the exact figures. So you got quite a bit of money to buy equipment to switch to this new technology. So on ISDN you don't have a modem because there's nothing to modulate or demodulate, it's digital. So it's called a terminal adapter, and it adapts the bit stream, the synchronous serial bit stream of the ISDN to your operating system or your computer. And there was something called V.110 as a rate adaptation to do asynchronous serial like RS-232 sort of over synchronous ISDN. Okay, and how did we get internet access? It was, if you're not in academia or something like that, there were a few commercial ISPs like Xlink or EUNet. They were very expensive, and of course you didn't have local dial-in in all the different cities around Germany, but you had grassroots groups of enthusiasts that established themselves in some associations to make sure the members can get internet access. In my region, in Nuremberg, Kommunikationsnetz Franken was particularly active. They started with dial-up UCP services and later for IP for non-commercial users, and I have to say with an extremely high technical standard, which I'm still fascinated by today. Kommunikationsnetz Franken had points of presence in various different cities in the region because not everybody could call to Nuremberg as a local call, and every user got 6 static IP addresses routed to wherever he dialed in. The use of OSPF in the mid-1990s to make sure you have static IP addresses wherever you dial in. Some people still don't have that in 2017. I'm not even talking about the static IP addresses, but anyway. So about 800 users peak at that association at the time. And there was an umbrella organization called Individual Network e.V., IN. This was established, individuals could not become members in that association, so the name is a bit interesting. It's called Individual Network because it's about networking for individuals, but the members were the regional associations such as Kommunikationsnetz Franken, who then basically used this umbrella entity to negotiate decent rates to get internet connectivity and so on. And apparently the IN members served more than 300,000 users at some point, so it scaled quite a bit. It was dissolved in 2000 when lots of commercial ISPs were around, and also when the remaining member entities, many of which still exist today, such as Kommunikationsnetz Franken, they didn't need this umbrella entity to get decent internet rates or tariffs again. So with packet switch TCP/IP, we just need one number that we call at some point. We're not dialing into hundreds of different BBSs anymore, but we're actually connecting always to the same number, which is our ISP. And then when we have that connection, we exchange packet data with systems worldwide, which brought new purpose to leased lines. Analog leased lines were basically telephone lines that were permanently switched or actually permanently wired at the exchange. So you had 2 wires of copper between one location and another location, and they were physically connected. You could apply a DC voltage and the DC voltage would come out at the other end. You could get this from Deutsche Post or Telekom at the time when I could finally afford one in 98 for 900 marks installation cost, and in my case 180 marks per month was 60 marks per hop. Hop means a telephone exchange. So if between the other end where you want to connect to and where you are 3 telephone exchanges, you had 3 times 60 marks, so 180 marks per month. And then I connected to a system that looked like this, which is called the Hub Nuremberg of this Kommunikationsnetz Franken, which is in the basement of one of the members. You have basically a PC running Linux or FreeBSD, no, it was FreeBSD actually, with like a 16-port serial card and various modems stacked on various shelves. To interconnect all these different leased lines, and which then had one ISDN leased line with 128 kilobits to some internet uplink. Yeah, that's the obligatory ISDN network termination and telephone sockets. Which brings us to ISDN leased lines. There was a product called SPV, Semi-Permanente Festverbindung. Which is not really a leased line, it's semi-permanent, and it's basically a flat rate call to one specific destination telephone number, which you could get in national 1TR6 ISDN, and which was rather inexpensive and what many people used who wanted more than the ISDN speeds. Okay. I have to speed up a bit, time is running out. The first step of abusing analog lines, which we did, is by deploying a device called an ICUT, which is the inverse of an ISDN NTVA. So in ISDN you have still the telephone exchange and you have a network termination, the NTVA, on your line. And basically the ICUT was a single line telephone exchange side of this protocol. So you could use an analog line, which you normally used for analog modems, but you remove the two analog modems, you put an NTVA on one end, you put the ICUT on the other end, and suddenly you can get 128 kilobits over that line, which previously you could only do 33.6 without having to pay any additional cents or money to Deutsche Telekom, of course. And then there were some special ISDN routers which could use the signaling channel, the 16K signaling D channel on ISDN also for data. So you get 128 plus 16 kilobits of data because, well, there's no signaling. You're not dialing anyone, so you can as well use that. Now, this is sort of the hierarchy of the leased line infrastructure at this entity. I'm not showing every leased line here, but basically I was at the upper left corner here, connecting with 33.6K to this Hub Nuremberg, which connects to 128K to a machine in a Nuremberg building of the University of Erlangen, which then connects over X21 to the University of Erlangen, where then all kinds of other leased lines come together. That was the architecture of what we deployed there. Some more pictures. This is in Fürth, a neighbor city of Nuremberg, the collection of telephone outlets and the collection of modems. And the machine, I'm missing one picture, sorry for that. Anyway, you can see a pile of modems here and some more modems here and the machine over there. And then we went into phase 2 of abusing analog telephone lines when the first DSL modems came out. So we imported some ascent DSL pipes in '99 from the US, and with some firmwares you could operate them back to back without a DSLAM. So basically you operate one DSL modem at one end of the leased line, another DSL modem at the other end. And if you are close enough, like with a single hop at a single telephone exchange, you could get up to 2.3 megabits symmetric over your analog line. And that in 1999 was quite a lot of speed, especially if you're not paying for traffic or anything like that. Some less expensive alternatives came out. Okay, before I wrap up, a short detour, or one thing still to mention, another phenomenon back then. I'm not sure if this happened in other cities too. In my area in Fürth, we had an entity called Falkensmace, which was called an online bistro. I became a regular there around '94. They initially had 4 DOS PCs, each of them with a modem and with a dedicated call charge meter. And you could basically go there, it's a cafe, you can eat and drink and so on, and you can sit at a PC and you can then from there dial into BBSs and basically do things if you didn't have a modem or a PC at home. But the interesting part, of course, was that all the other peoples were hanging out, the other BBS users, sysops, and so on. At some point, the PCs were networked with 10base2, so people could play Doom when it came out. I think I'm not sure when it reached us in Germany, '94 maybe or so. The internet became more popular. It started subsidiaries, and we set up ISDN SPVs, the semi-permanente Verbindung, as an internet uplink from there. So that also, you can find some sources that this apparently or allegedly was the first internet cafe. I'm not sure if anyone else has contested that, something like that. Anyway, after lots of anecdotes, I want to give you some time for Q&A. To summarize, the first decades of wide area communications were powered by a community of enthusiasts, or rather communities that were disjunct and not connected, largely motivated by non-commercial motives. Of course, there were commercial BBSs, but by far not, without much corporate or government influence, right? There was no Google and there was no ministry that was putting censorship or something like that. The BBS community is a distinct subculture, so it has different norms and its different values, different from the ham radio guys, different from free software guys. Of course, some overlap, but still a separate community with separate norms. What I personally think is the big loss, other than the loss of picture on the screen, is that back then the networks were distributed. There was no single point of failure. The infrastructure was owned and operated by its users, by individuals. The connection speeds were symmetric, and there was no like data center versus consumer separation that we have in the internet day and age of today. And that's, yeah, see, I really think this autonomy and decentralization is a big loss to society or the community as a whole. Okay, some pointers if you want to read up more or look at some ANSI artwork or log into BBSs. The Telnet BBS guide, I can highly recommend that. You can also find the BBS I looked into. Okay, good. Which brings us to the point where we can have some questions.
The microphones here in 3, 1, 2, and 4, but first we have questions from the Signal Angel. So what's the question from?
The internet wants to know what was the highest phone bill you ever got back then?
To be honest, I don't remember, but for sure it was 4 digits. I'm quite sure it was quite devastating. Yes.
There is another question from the internet.
And there's another question. You mentioned that there are very few books around those topics. Which ones would you recommend regarding BBS, Usenet, and so on?
I cannot respond to this directly. I don't remember. I can put it together, and or people can reach out to me, or I'll put it in the slides when I submit them into the FRAP system. Sorry for that.
So we have a question from the microphone number 2, please.
Yes. Back in the 90s, most of the voice was uncompressed and actually direct. But modern technology is usually having voice always compressed, transferred over IP. Do you know of any modern modulation formats that actually can survive several codecs, voice codecs, for data transmission?
I'm not the expert on that subject. I know there are some codecs, yes, but they are extremely slow. So you are happy if you get something like 1200 or maybe 2400 BPS of data through a modem that survives multiple codecs. And then, of course, always the question of which codecs.
Okay, microphone number 4, please.
Okay, I don't have a question to Harald actually, but thanks for the talk. I would like to ask the audience, because many, I think, users and operators of BBSs are here, who want to meet this evening at, I would say, 9 o'clock in one of the seminar rooms for a talk about the back old times. Yeah, I would say some here. So I will try to lock a self-organized session at the seminar room 1415, I think it's called, at 9 o'clock.
Okay, thank you very much.
So see you there and talk about the good days of, and some more stories, I think.
There are still more people queuing up. Microphone number 4, please.
I've got a question about the political bulletin board systems. Could you tell us a bit about the CLNet and the fascist clone, the Tulenet? What was the dynamics back then and the fights? What were the conflicts in those boxes?
I have to admit I cannot say too much about it. I know, of course, CLNets was a network mainly for left-wing political activists and groups, and yes, there was Tulenets, a right-wing network, and I knew there was discussions and so on, and there were people trying to hack each other's mailboxes and so on, but I was not participating or involving in these discussions to an extent that I can really comment on it, sorry.
Microphone number 1, please.
Hi, Harald. I still remember when I started with an acoustic coupler, I did that because there was a severe threat of punishment if you used an illegal modem at the time from the Deutsche Bundespost. So I was actually never aware that a little bit later you could actually do a back-to-back DSL modem connection over an analog exchange. So at that time you did that. What was the punishment situation from the Bundespost or whatever it was called at the time, if they would have ever caught you doing that? Do you remember?
I have no clue. Yes, well, sort of. I mean, the how can I say, the criminal offense, I think, stopped in '92 when Deutsche Post was privatized. So until '92, it was a criminal offense to operate a non-approved modem at the German telephone network because it was government-owned. It was a crime, not a minor offense. But afterwards, I don't really know, to be honest. I don't think anyone bothered at the time, and nobody. I mean, we never had any trouble with these DSL things and so on that we did over analog circuits.
Microphone number 2, please.
Okay, hello, I'm from Taiwan, and I just want to share something interesting for everyone. In Taiwan is a small country in Asia. We are still using BBS, the largest site named PTT, and exported use SSH or WebSocket to connect it. And its source code is available on GitHub. Everybody can search it. Thank you.
Thank you very much. It's actually not just for Taiwan, but you can find many, I mean, maybe it's more popular there still, but you can find many BBSs that are still in operation today in many different countries, even also with BBS software that's free software and it's maintained now on GitHub or on in other repositories with contributors and so on. So the community still lives, but I think at least internationally it's very small, and I'm happy to hear if it's larger in some countries.
We have still time for questions. Microphone number 4, please.
So you talked about restoring decentralization. So what old systems would you like to see coming back? Something like the Usenet? I mean, it's still there, but you can't access it without paying a lot of money to some back gateway. So which technologies would you like to revive, or do you think are realistic to revive to have decentralization again?
I don't think the technologies necessarily need to be revived because they are to a large extent old and people are smarter, and the how can I say, the capacity and the computational complexity of what you can do today and so on is much better. So we can have much better technology, but the thing that I would like to see revived is more decentralization and more people operating their own technology, and that's just, I think, I don't really have a plan, and I'm not saying I have a vision. I'm just seeing it as a problem, this development, that basically it's a consumer-producer model, and especially with content delivery networks and with attacks on network neutrality and all these topics, it's always moving in one direction. It's basically turning the user into a stupid consumer and making sure all the control and all the content and so on is in the hand of large corporations. By the way, one interesting anecdote about I talked about the asymmetry of the speed, right? And with DSL, at least ADSL and the popular technologies, always the downlink is bigger than the uplink. I know in Brazil, a lot of people basically in small size ISPs, they did it the opposite way around. So they did one modem with basically a large downstream and small upstream, and then they on another line next to that, they inverted it by using a master modem on one side and a slave modem on the other. So then again, you had symmetric speed. So some people had creative ideas to work around some of the technological restrictions.
So microphone number 2, please.
I also from Taiwan, and I want to ask something for my friend. there are still like 500,000 people connected to BBS called PTT, today, and like there are 100,000 people online now. Yeah, so I think the community is not like.
What is your question? Can you please phrase the question?
I just want to add something for my friend. Yeah. Okay.
Okay. Yeah. Thank you.
Microphone number 1, please.
You talked about content of his mailboxes. Isn't it that the Freifunk community today is a possible way to get this freedom back from what you had in the mailboxes? The services they offered there, the Freifunk could do the same today with user-owned structures and so on.
That's very correct, yes. Freifunk definitely is much more in the spirit of the community-owned and community-run systems, and I see lots of similarities between the BBS community and what Freifunk is doing today, is correct.
Are you doing something with Freifunk?
Me personally, no, I'm not involved.
Thank you.
I think microphone number 2 is waiting way too long. Go ahead.
Hello, thanks for the talk. You mentioned that most people didn't have a TCP/IP capable operating system at this time, and I started to read recently about an operating system called Xenix, Xenix, that was actually developed by Microsoft and published in 1983 that could run on IBM PC compatible machines on the 86 processors. And I hear that in the Russian BBS systems, at least, it was very popular. Did you encounter any Xenix operating systems at that time?
No, I personally did not encounter Xenix. I read about it, yes, and I know I could have possibly run it on my 286 machine, but I mean, I don't think it was something that was readily available for affordable price to individuals, but maybe I'm wrong. No, certainly not. Okay, some people are heavily shaking their heads.
I think this is why it was popular in Russia.
Possibly. I do not want to comment on that.
You have time for one more question.
Okay, just wanted to note, in the wiki, the meeting is up. Search for BBS, and this evening at 9 o'clock, I think we can talk about all the details of running DSL on modem lines. I've also got some more details on that, and a lot of these modems left if you need some. But I think, so see you, Harald, at 9 o'clock?
Yeah, definitely. Thanks.
Okay, everybody welcome.
Thank you.
Thank you very much for the talk.